Today I'm going to keep working on a project, sort of like a self-promotion type tool, sort of like a portfolio of my abilities. And the idea behind that is that I can sort of a very quick showcase of some of my work and what I do. And as part of documenting that, hopefully other people can see how I work. It shows that I actually made the thing I'm saying I made. And it's also just a good way to sort of share my process. And I find watching other people to be useful, so I'm hoping I can be of use to someone else. I'm going to jump right into it. This is Altium Designer 17. I'm actually using a slightly older one. I should be switching up to Altium Designer 18, which is what I use most of the time. But at home I've got just the old one running still. I'm going to start a new project. File. New project. And it's just going to be a default PCB project. It's been a while since I've used it at home, so 2018. I'm just going to call it portfolio. It's kind of a the design's still a bit of a work in progress. I have an entire folder of sort of design notes, and I won't go through it, but I'll probably do that in another video. But ultimately, the names are important. We can always change it later. Okay, new project. Super easy. Obvious things, add a schematic. I'll leave it as a default template for the moment. And now I'm going to have a couple of aspects in this. It's going to have, I'm using an LED array, probably a Charlie-plexed LED array, because it's nice and easy. It gives me a lot of flexibility. Probably the trickiest part is I'm going to be using electroluminescent display elements. So I'm actually going to have sort of character text with bitmap import, which I haven't actually done in Altium before. I've done it in Eagle, and it's quite easy-ish. But I haven't actually done it in Altium, so that's probably going to be a bit of a challenge coming up. But obviously that means you've got sort of high voltage, high frequency, so that's going to be managed with the discrete elements of the comms buses to sort of talk to the Charlie-plex driver, as well as probably analog signals from potentially a potentiometer and a few buttons, as well as not actually electrocuting anyone and being in a decent housing. So there's a few different aspects and layers. That's before looking at putting anything complicated like Bluetooth, which is probably just over the top, and I find Bluetooth to be frustrating to work with at the best of times, just to get things to connect without actually hoping to have a seamless experience for the dozen devices that I send out. It's not like Wi-Fi or even a USB port. It's a little bit tedious, and I think it actually misses the point. So hopefully we can just sort of start with these few high-level things. So I know to begin with I'll need to put a few objects we're going to put in place, and we're going to sort of start at the high level. So we'll start with a shoot symbol. And, that's right. This is the old version. Oh man, I've got to update this. It's funny, you don't notice the differences between two versions until you actually try and go backwards. Tab, there we go. Designator. LED array. Now just call it LED array. Doesn't need anything special. Fill color was all fine. Parameters. Don't need to add anything there yet. That goes there. And I'm gonna have. Not quite sure how I'm going to do this yet, but we'll definitely have something for the driver. Probably a separate one for the controller. another one I need a power supply. So it's going to be tricky to design. That's fine. Literally the same thing I just did then. Sheet symbol. Power supply. So it probably won't have any I/O unless I put a sort of controller in there. Supply. No, probably a microcontroller. I might, up to the moment, I'll put another one in there for. So there's a microcontroller, and this one will be. Because it's the interface. So this might cover the small little bits and pieces. So this will probably be I/O. I just realised I didn't actually check the stream. Hey, cool, people watching. Hello. Yeah, user interface. There we are. And we'll call this the microcontroller. Let's change, just keep some of the naming a bit. Yeah. Looks a little bit authoritarian. We'll catch that. Okay, so this is kind of the high level what I think I'm going to need. Now the actual, the kind of chip I know I'm likely to use to begin with at the moment is actually going to be the EO display. And I'm trying to remember the model of it. It's an ISL something. Let's try. Good old Digikey. Caliplex. Okay, there's a similar one used, or it's the same one used by Adafruit. I actually had to look for a few different ones to sort of see if there was options, and there's not many. This has got nice drivers written, so why rebuild the wheel? Oh, it's an IS31, it's not even close. It's worth a try that. IS31 FL. Oh, look at that, it's already in my history. Okay. That's right, so yeah. It's fairly basic. Yep. .7 to 5.5 volts, that's good. QFN. The really easy part is it's not a whole lot of sort of I/Os. This is sort of the top level to the microcontroller. So that's what we're going to, essentially the ports we'll have over here. 2 seconds. Cool. So yeah, so we'll have a couple of ports. It's literally going to be SDA, SCL, SDB. Yeah, I might put audio in. It's just like filtering and local stuff, so it's not like there's any extra control there. Awesome. Alright. let's just do that then. This is going to go off the side, sorry. Come on. Alright. Place, so hit the key, sheet entry symbol, and so there we go. So we've got SDA, SCL, entry, SDB, and audio. Go back to the data sheet. Yeah, see address settings. So remember that. SDA, SCL. Shut down. Alright. So obviously that's bi-directional. And scroll is different. Okay, this is simply input, input, input. Cool. Okay, cool. So SDA is the only bi-directional one there. Microcontroller, we have absolutely no idea. I don't even know what that's going to be yet. Guess is an MSP430 or an MNOR or something similar. It gives me a few compiler options. Or maybe an Atmega 328p if I'm running out of time. EO driver, I have no idea there. EO control. Okay, so a lot of the characters are going to be just my name. So it's going to be letter ANDREW, then my surname VANDAM, and probably the 8 sort of I thought it was sort of like a Space Invaders type style. So the 6 ships down the bottom that do that. So my guess is we'll place a couple of ports there. Place sheet symbol. Place sheet entry. That's me. So the first one. I might just do this as a bus. I know for sure that is wrong. I know buses are going to be something slightly different. I can't remember off the top of my head. I think it needs some dots in there, or it'll end up with some dots in there. I'll have to double check that. Driver, I have no idea. User interface. At the moment, it's a potentiometer and a button. Okay, that's not exactly challenging. Place. Sheet symbol. Again. Place. Sheet entry. There we go. X, Y, button A, B, can I really forgot how different this one was. Where are we? Favorites. There's view, toolbars. Schematic. So the new version, it makes dealing with properties really easy, like really easy. Like you can just easily group stuff and change sort of common aspects. I can't remember if it is a schematic inspector. So, okay. So there's all outputs. Okay, cool. Why don't they bother to change the name? I suppose it makes more sense the other way around. User interface. Put X, put Y, button A, button B. Power supply. Could be anything. Or control could be anything at this stage. So the main thing I want to do is start getting some of the structural elements. So the LED array will sort of set a lot of this sort of style and takes up a big chunk of the board. So hopefully next time I'll have it with me. I've got an Illustrator document that sort of is a rough plan of my layout. Because this is more of an artistic sort of display and sort of board than most other boards, so the actual appearance of it is really important. So I've actually mocked it up in Illustrator to sort of try and get a feel of the dimensions, the fonts, and how everything sort of looks with the right amount of sort of, whilst it won't be white space, it'll be black space, you know what I mean? So that's sort of what it looks as though really is sort of the, not quite 50%, but at least sort of 40%, and the bulk of the center section will be taken up with this Charlie-plexed array, which is going to have lots and lots of traces running between it. Even though they'll all be set up in rooms and quite structured, it could be potentially difficult to route other signals around that, especially considering some of those signals will be high frequency AC. Again, it's going to be interesting how sort of the noise in any crosstalk. I'll have to set sort of specific net classes, I think, to try and avoid some of this and make sure my clearances are big enough. But we'll get to that when we get to it. Let's make this a little bit prettier. Da-da-da. Okay. Alright. Now, sheet symbol actions. Create sheet from sheet symbol. So the really nice thing about that is it actually puts the ports in there already. So we can be nice and lazy about that. The less nice thing is how there won't be any vault component for this. I'm like 90% sure. I find the Altium vault really, really hit and miss. Like, sometimes you get lucky, sometimes you don't. We'll see how we go. Okay, here we are. IS31, let's see how that goes. I'll put an asterisk in there. For luck. I think that, yeah. I'm not sure that one. Nope. Looks like we're making our own part. So, add new to project. I don't really have my own sort of schematic library or PCB library I'm already building up. I try to generally build libraries and keep stuff together. It makes it much quicker to bring stuff in. And I don't have enough components and stuff to sort of make separate libraries yet for connectors or potentiometers or whatever. But at home I don't tend to have a lot. I think previous projects I've used, yeah, sort of general work libraries, and I don't want to use that for this, so I'm going to make a new one. Add new to project, schematic library. Okie dokie, let's build a part. Okay, what do we got? Better mock-up. Here we go. So we'll just actually base it completely off their prototype because it's easy and it obviously looks like it works. pins. Display name VCC. This is VCC. No, it's actually in 2. So it's nice and easy when they can be diagrammed like this because it's just literally copy and paste. Yeah, it looks like price packages are the same. I'll probably use the SSODS package, purely because it's a lot easier to size than the QFN one, but if I get a bit tight for space on the back, which is quite possible, I might need to switch and then have more of a nightmare soldering it. But we'll see how we go. Okay, this is probably just going to be a little repetitive now as I do this. This is where I need some sort of smooth background jazz. Passive. Okay. Why is my text not? Yeah, why is my text not rotated that way? There we go. That was odd. Obviously did something earlier. VCC. SDA. SL. B. 4. Power. Let's fix this. SDB. 3. Digikey. Now. IO. BCC. Most of these are inputs. Except for SDA, which is input and output. Okay, place pin. They just call it in, but I'm a little bit specific. In data 17. Excuse me, in there how to have it. Oh, where's that damn thing? Input. Okay. Underscore external, which is the current set resistor, I think. Passive. There we go. 99 times out of 100, the IO direction doesn't really matter, like you can get around it. Let's see filter. I'm pretty sure. Yeah, see, like, for me, when I come back to this, for me, it should be like filter cap. But let's behave ourselves and stick with the existing document. Make it a bit easier for everyone else following along if I end up sharing this library. Which I don't tend to bother with Altium. It's expensive software, it's not like it tends to be used for open source stuff. Whilst it's always good to share, people just don't tend to, it's not like other stuff, so it just doesn't get picked up as much. Ground. Alrighty. Is that? No, that's the right thing on that. No, I did not. 5. AD, did I set that right? That should have been 18. I'm too busy caring about what C filter is. That's the important stuff. So that's all there. Now, the rest of it is sort of the array driver. It's actually a kind of odd sized array. It'll actually do 9 by 16. Yeah, and it draws it in sort of 2 matrices. So actually, the one way that syncs and one way that sources. The cat is helping. The wife is running away. The cat's hungry, it wants food. Which is kind of a clever trick. Like, this obviously massively increases the size of the array and reduces the number of chips they need inside it. Yeah, I like it. It does make the actual wiring a little bit different. Like, it's a bit of a sort of like when you actually look at the way they sort of design these nets, it's when you try and look at it the first time, it's a bit bizarre trying to look at how it and where it all goes. I tend to favour using net labels as much as possible. Whenever anything gets confusing that way, I find it's a bit easy to sort of look where names go. Sometimes you get a huge mess, it gets a bit off-putting. Anyway. Place a pin. Start with CA1. Designated 21. It's convenient. And just feel that as passive. It doesn't matter so much. Okay, CA2 is 22. CA3 is 23. CA4 is 24. 5 is 25, 6 is 26, 27, 8 is 28, and CA9 is 1. Ah! Now we do the CB. CB1 is 7. And nice and easy, they're all sequential for 7, 8, 9, 10, 11, 12, 13, 14, 15. So all the way from 1 through 9. So everything auto increments. Okie dokie. Come on. Move selection. Why are they locked? Ridiculous. Put that down a little bit. I'm going to drop that down a little bit. So it looks like, so here you can sort of see C filter, but inevitably by the time you try and actually put a cap in here, you want a little bit of space there so it actually sits nice. It's not like where they've drawn the schematic here. So actually we'll put AD all the way down because that just connects right to ground. C filter, our external go up. Gives that plenty of sort of got the room. That's everything. Alright, now we can place a nice pretty rectangle. Oh, pretty. Range. Align. Ah, that's what I did. Okay. I don't think it's the same shortcut as No, it was too much to hope for. Okay. Tools. Ah, that'll move. Okay. Seem to back off. Send it back. There we go. I'm not going to bother with the footprint at the moment. We can deal with that chestnut later. Schematic library component 1. Properties open on a different screen. Alright, default designator. Use default comment. IS31 FL3731. That. Array driver type standard. Symbol reference. Put 1 parameters. Models. Add. Okay. That'll do for the moment. IS31 FL3731. Okie dokie. Now we're gonna add completeness, and it makes it so much easier when you do this. Add a supplier. So this should go through. I think I use maybe they use spine chips. I'm not sure. But either way, it's gonna go through Digikey. That's where I buy all my stuff from, just about. Set up my preferences for this. Don't care about any of these currencies because I'm not running a factory halfway around the world, but US dollars and AU dollars is handy. Location. Supplier. Allied electronics I won't use. Arrow I won't use. Digikey is pretty much the only place I'll probably use. Let's get rid of far now. I don't use much of their stuff. Element 14 is kind of handy. Mouser, alright. Newark. RS. Yeah, they can sometimes be useful. Okay. Apply. Okie dokie. Alright, let's search that again. Uh, 500 fruit parts. Okay. Mouse. This is the QFN package. Okay, that's that one. Alright, let's check the supplier part number. There we go. Ah, okay, parts, there you go. I'll try. Cool, yeah, that's the SSFG. Just check that's quantity 1, yeah, so that's cut tape. One thing I've yet to work out, so you can have multiple footprints for parts, so you can have your SSOP or your QFN, but I've not yet worked out how you can link the BOM part or the supplier part to the relevant package. I haven't worked out how to do that yet, and that seems like an important thing to work out, so I'm going to be keeping my eye out on that one. Model, don't need to worry about because we're not simulating it. Aliases, no, okay, cool. That's easy start. And what can we call this? Actually, let's make this as part of a broader library. So I'll put this in here. So you can see cops general. So I tend to use my work one because when I switch them back and forth, it helps build up that work library. Seems useful. Actually, we'll call it Moam general. Save. In fact, while we're here, we'll save it all. File, save all. Portfolio, AVD promo, LED array schematic doc, yes. I'll just call this top level. Unimaginative but descriptive. Okay. Libraries. General. Oh, look, it's the only part. That was easy. Alright. U1. I do like this trick. This is a very satisfying trick. Tick. Pew. And VCC. Let's just assume we're using 3 volts, 3.3 volts. Probably are. So ground. We'll probably need digital and analog grounds, but we'll deal with that later. Libraries. Miscellaneous devices. Let's add caps and resistors. Let's close messages so we get a little bit more real estate. Libraries. There we go. Let's go to 603. No idea what that needs to be yet. We want a resistor. Honestly, so frustrating. Resistors, axial, axial, axial. Never quite understood why sort of the default Altium library is kind of useless. Like it's got a really weird selection of stuff for some of the tutorials. Well, I showed some of the tutorials, but you do the actual tutorials and they give you different files anyway. So it doesn't make a whole lot of sense why they include such a sort of strange smattering of built-in components in the miscellaneous devices one. Maybe there's something I'm missing. Kind of hope there's something I'm missing because it does seem a little bit odd. Damn it, I just realized I closed that document. Let's see how this works in here. Schematic inspector. Okay, so in version 18, it's very quickly, you can sort of go straight from the properties and open up the data sheet. There might be a way to do it more in here, but in the short term, I'll see if I can just go straight to. No, that's okay. Data sheets. So I have no idea what current I want to set yet. So that's what. No, go back. So that's what our external is. It's a formula. But that formula is hidden somewhere in this document. Do you see address settings? Okay, yeah, alright, looking at that, I made a mistake with the AD. So previously I said that just connected straight to ground. That's actually the device address. So if you wanted to set different addresses, you'd connect AD to different signals, which was there. However, we only got one device, we can just set it to ground. Big whoop. EXT. One of two mentions, that's not easy. Okay, that's what I wanted to see. Oh, print screen. MS Paint. Good old MS Paint. Let's save. Oh look, the cat's back. She's suffering again apparently. Recommended minimum value is 18k. Alright. That's kind of weird. So it's like they've automatically scaled it for K. So REXT is actually in kilo ohms. I don't like that. When I inevitably look at this and 5 months later and get confused, hopefully this will save me. There we are. Yeah, it's pedantic, but I figured it might trip me out. Alright, let's run some wires. Bang. Bang. That was silly. And a junction. There we go. I hate the look of that manual junction. There we go. Alright. Weird. Place wire. I'll probably put filter caps elsewhere. I'll deal with the naming later. I'll just run that as a batch job. That's all okay. Okay, so the next part is the LED array. So I want to use through-hole parts. Sorry, well, not through-hole, so SMD, but they're designed for reverse mounting. I figure you could probably reverse mount any SMD LED. I've never actually tried it before. I might pull out a board another time and give that a shot. The main reason they're definitely set up for is so the pick and place machine actually comes and grabs it on the bottom instead of the top, so it actually shines through the hole. That should give me a nice flat surface that I can do the screen printing for the electroluminescence and hopefully make it look nice and clean. Like, you see sort of a lot of badge designs which this is sort of loosely based off. They yeah, I was looking at this the other day. They have a nice little collection of some of the ones from DEF CON. Blockchain badges, there we go. Oh, it's going to disappoint me now. This is, wow, these have gone back a really long way. Alright, well, I'll use this one as sort of a talk piece. So they're quite cool from a technical perspective. They look really interesting, but they always look a little bit sort of, they try to showcase the electronics instead of understating them, if that makes sense. It's sort of, whereas the style and design I'm thinking about more as a sort of a bit more polished and clean, and I suppose the best way to describe it is a little bit more professional, as opposed to sort of like a flashy showpiece, even though it's going to flash a lot. There we go. So it's sort of, they always, not always, there's some really incredible work, and some of them, oh, here we go, just brought it up. Like some of them look absolutely stunning, like sort of the artwork on these, it's just beautiful. Like this one in particular I quite liked. It's got this sort of really beautiful artwork. I'm no artist, like I'm not sort of, I don't have that sort of drawing artistic ability. Even though I could translate it, it's not really my strong suit, and it's not where I want to spend the time on this project. I'd rather sort of show something that's a little bit technically complicated, sort of with the electroluminescence. It's something that I don't think I have seen in something like this ever. I've seen people use electroluminescence screen printed a little bit. There's been a few people who've done it. I've forgotten the woman's name off the top of my head. No, it's completely gone. But essentially using sort of screen printing electroluminescence onto PCBs is not a new thing, but it's kind of cool to do it in a slightly different way. A sort of self-promo, and it's not something I've seen done in these badges. Yeah, see, this one here is really cool. But again, it's sort of, it still looks like a bunch of parts put together without it actually being a final project. Like sort of chips are used as sort of focal points, which I think is a cool look. It just doesn't look like a polished, finished product, like a consumer type thing, and that's, in my mind, sort of a slightly professional route I'm going to take this board. It should sort of almost not even be obvious that the board is a PCB from the front, which is going to make it quite tricky, especially with vias. So you have like blind vias on the top, and it's sort of, it'll obviously be a PCB, but we'll see how well I keep that. That was quite a cool style as well. Yeah. Anyways, I've started to ramble. Oh, were we? Okay, so that is that part there. Okay, LED array. Okay, schematic library. Add LED RM for reverse mount. It's a bit horrible. And it ought to be sort of 0603. Let's leave the size out of it for the moment. LED reverse mount. I've had a cool trick earlier today, and I'm hoping I can use in this version. LED, there we go. Command C. Paste. Haha, forget that trick. Yeah, delete that. Okay. what do they call these? Anode, yep, cool, and cathode. Okay. Save that. Now, where did our other document go? Cool. So I'm just going to quickly do this. Yeah, I might need to have a bit more of a read to double check. But the plan is, oh, way up here, goodness me. I'm actually going to do mine 8 by 12 from what I sort of worked out for my sizing. I could probably shrink it down to 7 maybe and sort of shrink up the space a little bit, but 8's a little bit of a nicer number to work with. 9 is a bit too big. It's all semantics, but so at least with 8 I can make really sort of nice scrolling letters and numbers appear. That's at least what I hope. Although having said that, 9 works really nicely if you're trying to do, yeah, look at that. So if you do, so if you see that as an 8, so you've got like 7 segment 8, so you go 3, that, 3, and then like, damn it, 9 works really well. Although if you do 8, you could do 1, 2, 2, 1, 2, 2, 1, and just drop out a row. Doesn't look as pretty. Well, this existential crisis, this will have to come in later. I think I can make 8 work. I really want to use 9 now. Well, there's something else to mock up. Alright. Okay. Either way, we've got a big array of stuff to do. And the trick is going to be fitting it all in. Got that. There we are. Okay. Oh, that's interesting. That didn't copy over properly. I have to do that. I'm going to grab myself a drink. I'll be back in a sec. Digikey, where was I? Oh yes, I was going to put down 500 LEDs, but first I was going to work out why this one had not copied properly. So back around, C, paste. Yeah, that was weird. No, let's copy just those parts. Why did that? I see. No, we just delete the whole thing and paste the whole thing again. C. There we go. Save that. Okay. Let's make sure we actually use the right LED. Libraries, general. Now what prefix do they use on theirs? That's D. Okay. You know what, the smart thing to do is just rename that. Reverse mount. Okay. Place part. LED RM. Okay. That's right. You have to save that. Place part. LED RM. Order just not updating. Place part. Choose. That's right. If you use the history, it takes a different version. There we go. Oh, excuse me. That one snuck up on me. Alright. Now it's not cheating, it's being smart. We're going to use their convention. Okay, so they use. There we go. There we go. That's weird. Place part. Choose. LED RM. Okay. Designator. C1-1. Okay, that looks too. Oh man, did you hate me on that ring? 9, 10, 12. I'll run the full array because we can just cull it back later. 14, 15, 16. That was probably an odd noise for you guys. Sorry about that. Okay, bugger. Okay, I think I know because there's two ways I can do it. I can either split it into another sheet, but it seems a little bit pointless, like sort of starting to offset stuff for no real reason. It's not providing any extra clarity. There's not even a lot of signals going through. So I think I can maybe just move this stuff around. Bring that down there. Okay, there we go. 8, 9, 10, 11, 12. That's all I need. Okay, you can just bugger off. Let's see if Smart Paste can help us here. Please. Smart Paste. Alright, we'll just do it as an array. One column. How many rows? Haha, that is the question I was asking. We'll do 8 rows. Spacing, they look like they're on a what? 1, 2, 3. How many mils is that? 2, 3, 4, 5. Plus I want 6. I think 600. 8, 600 on spacing. Yeah, our numbers just getting up horrible. Yeah. Let's see what that does for our naming. That 600 spacing is not right. That is so wrong. Oh, it's a 10 mil grid. I'm an idiot. How does it do the naming? C1-2. Naming made no sense. Smart Paste themselves as an array. Alright, let's go with 60. Yeah, I don't get that. I don't get why that doesn't make much sense. I'll do with that later. And that is only just going to fit. There should be an A4 page by default. Oh man, it's just looking a little bit too. I know what I can do. Okay. Alright. So let's start with use library name is fine. So reference that. I don't need to see. I need to see the designator. I don't need to show. Man, it's so weird going between versions. I'm going to be so out of things tomorrow. C1-1 part comment. Okay. Alright, I'll just have to delete the comment in this version. Okay. Pew! Gone. Alright, there we are. We can just jam it all right in there. Eight, 9. Yeah, it's gonna fit a lot better. 12. Put it right up there. Copy that. Edit. Smart Paste again. 1/8. I probably would have got it before. Okay. And that labeling is just all over the place. Oh, here's what it is. This is interesting. I've just distracted myself with my stream health. The grand total of 2 people watching. I'm pretty sure one of them is me. It's kind of funny. This whole purpose is more for documentation than anything, but there's a little bit of vanity steeps in. You want to sort of see what you're getting at. But the stream health is quite interesting. So where we are, particularly our part, we have terrible internet here. Like, I think 1.5 megabits a second up, and that's if you're not doing anything else. And about 4.5 down. Yeah, it's pretty woeful. Sort of, yeah, YouTube doesn't like it very much, but it is what it is. It does have a surreal feeling that there's only 2 people watching. You're sort of talking to yourself. This is the first time I've really done live streaming to any amount. So yeah, it's weird. It's not a motivation tool though. Like, I've got more done in this hour than I think I normally do of an evening, because there's this distraction. You have to do this. You're streaming everything. You sort of want to keep everything rolling. So I'll definitely be doing it again. It's like a sort of public watching over your shoulder thing. It's quite, yeah, it's a bit weird to describe it that way, but yeah, it is what it is. Anyway, back to the layman parts. Component designator C2-1. Yeah, that'll work. And I'll just go through and manually update the names. There's probably a better way to do this, but C3-1. C4-1. Just use crossing select. Look at that. C5-1. C6. C7-1. I need to have a look. I have to read that data sheet properly. I've only sort of skimmed it. Just got to make sure there's not anything weird with only sort of partly connecting up some of the array. I think it just means that you just have space you don't address, and you're probably gonna sort of overscan. Like, you could scan things a bit better, but I don't think it's going to affect visibility. C8-1. There we are. C9-1. This is all coming up Millhouse. Okay. I wonder if actually if I could use the annotation manager for that annotate schematic. Yeah, see, I wanted to annotate in rows and columns, so it like sort of sets things clearer. I don't know. Yeah, I don't think there's a way to do that. I think it just does increments everything. No, I just have to sit here. You might want to scan ahead if you're watching this later. This is going to be boring. I think I can. Yeah, okay, just like partially edit it. That's a shame. I'm actually quite impressed with how much they've actually changed in 18 having used this one. Like, being able to use a selection filter sort of cuts down on the number of clicks you have to do. Like, little things like that actually do make the workflow quite a bit nicer. No, I'm glad I'm not doing all 16 now. Actually, I was going to cheat through these ones first. So much clicking. Alright, let's do the 9s. 9. It is nice seeing those little red squiggles disappear as you do this, so I think I'm going to stop the stream in a little while because my eyelids are getting ridiculously heavy. I had a late night last night, so I'm sort of regretting it now. Another early morning. Let's just get this. I kind of want to get this connected up. That seems like a good place to leave things. Just like get this schematic done. Nope. Probably didn't even need to go through the effort of this. It's really just, I could have given them all unique numbers and it would have been fine, but a little bit of sort of completeness, like it makes things clearer, less likely to have mistakes when I'm sort of checking how things are mapped out. I can sort of actually check. I don't have to sort of remap things in my brain too much, especially with this many connectors in here, or many devices, sorry. It would have been nice to have been able to do this in rooms. So the idea is you put other schematic, like you do sort of a sheet of sheets, and you just then have this array that bulks out. But I didn't think I could do that because if you look on here, it's not like sort of a direct sort of row to column relationship. So sort of CA1 is connected to sort of all the top elements. So all the cathodes sort of here, but then it's also connected to all the anodes sort of running down. And still, for some reason, my mind has gone blank. I'm not even sure I'm using the anode cathode the right way. And I'll be embarrassed if I've got that wrong. Yes, anode cathode, that was right. A, C. Anyway. So my thought was I couldn't see a way to do that easily, where everything was the same. Like I could do sort of like a matrix block. Yeah, you could maybe do sort of, you could have done it. You see, this is the thing though, so like each one of those is sort of, each of those cathodes is connected, but each anode is different. So that one, I guess that one connects there, 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 there. I guess that's where the diagonal goes. Yeah. How would you have done that? I don't think there is any way you could do that. Certainly not visible to me at the moment anyway. Let's just renumber things for a little bit more. 5, 5. There. Now onto the 4s. trees. If the dog is groaning over there, he's had a hard day of sleeping, he needs more sleeping time. Apparently I'm interrupting him, although he could also be wanting dinner. Probably dinner. You been out, Moose? I don't know if you tell me the truth. Let's say he hasn't. Actually, nothing. Anyways. Twos. Thankfully, the one's already done. Look at that. Double red's disappearing. How does that happen? Okay. Now the split for the two groups. So after the 8, so 1 through 8. So then 9, 10, 11, 12. Oh, excuse me. Oh. Okay. So 8 across. Let's give it a little bit of a gap. Oh, that's a resume that's not that interesting. Where's it gone? There we are. Okay, so yes, that's bar, bar, black. Okie dokie. Placing wires. Oh, make that one a bit shorter. Okay. Now. So that runs like that. Awesome. And now it's preferences. So like, also tends to be a little bit visually overpowering. I like the loops visible. It makes it a little bit, I don't know, a little bit more obvious where there's a connector and where there isn't a connector. But this is going to take me a little while to set up because I'm not even sure where it is in here. That's probably under here. Preferences. Oh, yeah. System. View. Transparency navigation. Schematic. That might be it. There we are. Oh, look at that. It didn't even take that long. Alright. Now, every single one of these goes like that. See, this is where it would have been handy to have a bit more space. How much space have we got? Probably not enough to be flippant with that. Let's see just how bad it looks. It's just easy to say, oh, it doesn't matter how it looks, but at the end of the day, it can make a huge difference to readability and like how easy it is to use. So it takes 5 minutes. Now, it might save you like a day later as you're trying to fix up some mistake. It's probably a little bit dramatic, but there we go. Oh, look at this, swimming along. Yep, everything looks like it's hunky-dory. This side is almost relaxing. I don't know if I'm doing that. Placing the wire. Okie dokie. So these all tick. Oh, no, I lied. Everything goes. So goes on a, okay. So what I'm doing is everything goes left, sort of that diagonal. So when that diagonal goes down, it sort of sets a divider with things. So left on one side, right on the other. I'm kind of really curious to know how this chip works now. The sort of way the gates and stuff drive things. I've got to need a bit of paper. I can work that out. Sort of wrap my head around it. Not that it really makes any difference to how I'll actually use it, but just curious. This chip's older than I thought. May 2013. Excuse me. It really must be been done. Yeah, a few years old. Alright. Well, I think I'll run the stream out to an hour and a half, and then I think I'll give it a rest. Okay, so place wire left, 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 right, left. This is where having that naming convention, that effort there makes it worthwhile. So I can just go, okay, C2, 2 is right, C3, 3 is right, C3, 2 is left, C4, 4 is right, 5, 5, So I can just look at the double digits and go, okay, double digits go to the right, and from everywhere from then on, right. See, I knew it would pay off. Nothing like a self-fulfilling prophecy. So 2, 2 goes right. 3, 3 goes right. 4, 4 goes right. 5, 5 goes right. 6, 6 is right. I really hope I got this right because this is going to be a pain to redo. 7, 7 goes right. 8, 8 goes right. Okay, which makes sense. 9, 8 goes left. Everything else just goes left. Awesome. The thing I need to remember is that each of these verticals has to be tied to a horizontal at some point. Lefts first. And okay, then we go right. Right, 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 right. Said Fred? I think that's a band. I don't see wonder how many like almost completely unwatched live videos there are. I'm always impressed by YouTube systems, sort of the sheer amount of data they must have. And from what I can tell, they don't delete any of it. Like, surely there's a massive cost associated with that. Okay, so now place manual junctions. So 1, 1 connects to A2. So what I'm looking at, so 1 dash 1 A2, 2 dash 2 ties to CA3. CA3 3 connects to CA4. 4 4 to 5, 5 5 to 6. Okay. See that dodgy list paying off again. Let's see 1 1. Bang. 2 2. Yeah, so CA2 that will be CA3. 3 3, 4 4, 5 5, 6 6, 7 7. Yeah, see 8 dash 8 is connected already. So that's there. Just went a slightly different way. Alright. I'm kind of getting ahead of myself, but what the hell? We'll actually need to give these proper nicknames though. There's heart. No? That's strange. I actually thought they matrix A and matrix B. For some reason in my head, A and B share sort of common setup, but they actually don't. I don't know why you would do setups that way. I'm sure it makes sense in the silicon somewhere. Anyway, that's me done. I'm signing off. This has been fun. I actually quite enjoyed it. I think I'll do it again in the future. It certainly keeps me more accountable for my time, so it's got value in that way.